numbers with numbers, letters with letters. 30x cubed y squared. 28x to the fifth y to the fourth. 2/5. 3a squared. 4/u squared. 7u squared over v cubed. 64m to the 12th, because the 4 has to go to the 4 as well. 27n to the 9th, because the cubing has to happen to the 3 as well, because it's in brackets. Any questions from the first page? Pardon? Of course it was quick. You already know how to do all this. And it's been marked in front of you. (16a squared b to the negative 2 over 16a to the fifth b squared. 16's cancel. Those two a's cancel, leaving you with 3 down there. And these b's have to come down there, giving you 1 over a cubed b to the fourth.
What? How did the b's work?
It's a negative 2. Negatives can't exist, so it has to come down there. There were already 2 down there, so now there's 4. This one is 4xy to the x squared y to the negative 2 over 192 x to the fourth y to the fourth. I know it's blue. Numbers with numbers. 48 on the bottom. X squared on the bottom. Y to the sixth on the bottom. And a 1 up top. GCF. List out all the prime factors. That is 2 to the sixth. That is 2 to the fifth times 3, and 2 to the fourth, which is 16 times 9, which is 3 squared. GCF is everything common to all of them. 2 to the fourth, you can see, it's 2 to the fourth, which is 16. And the LCM is everything once, so 2 to the sixth and 3 squared, which is 2 to the sixth is 64 times 9, which is 640 minus 64, which is 586, I think. Yeah, 586. Oh, you only had to find the GCF. What a dumbass. LCM 24 is 2 cubed times 3, 2 to the fifth, and 2 to the fourth times 3. So the LCM is 2 to the fifth times 3, which is 32 times 3, which is 96. Okay. Now, what we did yesterday, which is leading into your quiz today. Your quiz today will have 5 multiple choice exponents questions and 9 no multiplying, just simplifying of radicals, which is this stuff. which we did a couple of days ago. But because we did work yesterday on multiplying radicals, I'll do a few of these because you'll get to practice the simplifying of radicals. So this is, of course, 90 times the root of 25, which is 90 times 5, which is 450. This is 9 times 6, which is 21 root 6 times 2 root 6, which is 42 times the root of 36, which is 252. This doesn't get any simpler. That is 9 times 3, so out comes a 3. So that is root 15 times 9 root 3, which is 9 root 45, which is 9 times 5, to get us to 27 root 5. We remember numbers out front multiply with numbers out front. Numbers radicands multiply with radicands. Always better to simplify before you multiply. Now, the other way that I showed you guys how to do this, 12 root 20 times 45. You put it all under there at once. 20 is 2 squared times 4. 45 is 3 squared times 5. There's a square. Sorry, not 2 squared times 4. 2 squared times 5. There's a squared. There's a squared. There's a squared. So out is going to come 2, 3, 5. You already had a 12 out here. Did I leave anything underneath? No. So it's 360. You could just write it like that, assuming you have done this work and show me, because you could also write 360 by punching that into your calculator. And I do not care if you know how to use your calculator. I care if you know how to do math. And they are significantly different things. This is, of course, you could write it all out, or you could go 8 times 2, because that's got a cube root. So that's 6 cube root 2 times 2 cube root 4 times 2 cube root 2. They're all cubes, so that is 6 times 2 times 2, 24. Cubed root 2 times 4 is 8 times 2 is 16. That is 8 times 2. Cubed root of that is 3. So that is 72 cube root 2. These ones, we talked about these a million times. You have to pretend like that's not there. Then you do the work. Then you pretend like that's not there, and then you do the work. So that is 4 root 21 minus 8 root 15. And of course, 21 and 15 do not simplify. This is, I know it's blue, is root 48 minus root 16. Then you simplify. That is 16 times 3, and that is 4. Out comes a 4, and you get 4 root 3 minus 4. And then you're done, because you cannot put them together, because this guy has no radical. This is the same all the way down. You would multiply that one through, simplify all these, simplify all these, simplify all these. So I'm going to leave that for now in case you didn't do it. This page is the same type of stuff. Now your quiz is going to have questions like that on it. Only one single simplification. Okay? And everybody was here for that. All right? And 4 multiple choice exponents questions. Everybody cool? Now to remind you, because I am a fair person, 6 square root of 112 If you're going to simplify that, you break it down. And you see that it is, there's a group of 2, so out comes 2. There's a group of 2, so out comes 2. I left 7 under there. 2 times 2 is 4. 4 times 6 is 24. And I'm done. That's what your quiz is on right now. Everybody cool?
How would you do it the other way around?
What do you mean the other way around?
Making it like just like.
Making it solid?
Yeah.
Well, if you were going the other way around, which I'm not asking you to do on this quiz, and almost never would I ask you to do that, if there's 1 6 out here, that means there had to be 2 6s under there. So this would be the square root of 112 times 36, which would be a huge number, but I don't. If you showed me that, I'd be happy. Everybody cool? All right. Now, nothing on this quiz is new. You have already done a quiz on exponents, and we are 2 lessons past any of this. So everybody should be just fine with this quiz, yes? Now listen to me. You're going to cry and whine, but that's okay. I'm only going to give you 10 minutes for this quiz. It is not anything to be stressed about because it doesn't count against you. Again, but this stuff on this quiz, I lied. The exponents are a little harder. I will give you 15 minutes. The stuff on this quiz on the back page, this stuff is so important to further math, to be able to simplify a radical quickly, that it's kind of like knowing how to add now. Do you understand what I am saying? This, which seems a little difficult right now, in grade 11 and 12, needs to be at the same level of being able to do as adding 12 and 7. Do you all understand? That is why I'm putting the time pressure on you, but I'm only putting that time pressure on you on quizzes that do not count. Aight? Aight. Remember, the first 4 are multiple choice, so use your heads. You don't necessarily need to work it all out to figure out what the answer is in multiple choice, right? I will hole punch these, I will bring them around, put your name on it, and then I will start the time. I won't bring them around, you will pass them back there. You pass them to the right, at the back, or your left, I mean. I will bring these over here. Yes, you do. Boom, 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 boom. And you should be engaged. Go. I don't care. If you want to, go ahead. is there another relationship, something you can do mathy to the number 9 to make it equal 3? Square root. Is there something you can do to 27 to make it equal 3? Cube root. Is there something you can do to 625 to make it equal 5? The fourth root. Now, does everybody see how rational or fraction exponents work? It's pretty obvious, yes? 9 to the 1/2. Where on this side, because you can see the 9 is on the left and this is here, where would the 1 and the 2 from here go here? The 2 would go where? Where?
On the top.
Right there, because it's the square root of 9, yes? And how many 9s are under there? 1. Where would the 1 and the 3 go? Here. The 3 becomes the index, and the 1 becomes a power. Everybody see? Pretty easy to follow, right? So, let me ask you this. Don't write this down, just look. If I have x to the a over b, what will it always equal? 2 seconds ago, you all saw this. Now, I've taken it away from you. I expect you to remember something from 2 seconds ago. Remember, 9 to the 1/2 equaled the square root of 9.
Oh.
So, what is this?
X.
Square root of b?
Square root.
The b root of x
Power A.
to the power of a. Everybody got it? Pretty easy, right? And once we see this, we know how to work it, don't we? So let's go back over here. Now, did your printing screw up like mine? Is the A right below? Yeah, okay. So here's what we're going to do. I'm going to rewrite B over here. 27 to the 4/3. And I'm going to white out this B. All right? Everybody cool? Okay. Now, in A, you notice that in all of these, what happened to the base when I put it into the radical form? Where did the base end up? It became the radicand, right? Does it matter what the base looks like? Of course not. What's the base here? 0.04, right? So what's the radicand going to be? 0.04. Where did the denominator from the exponent end up? The index. Where did the numerator from the exponent end up? Power. Right? Now, we're very intelligent young people. I'm a very intelligent old person. We can figure this out, can't we? This is yucky. What is that as a fraction? 4 over what? 100. 2 decimal places. And that is square rooted, yes? And then all of that is cubed. How do we write this in a prettier way? If the square root goes around everything, then what does that mean? It means the square root of 4 over the square root of 100, all to the 3rd power, right? What is the square root of 4? What is the square root of 10? What is the square root of 100? 10. And all of that is cubed. If there's a power out here and there's brackets, where does that power go? To both of the numbers to give us 8 over what? 1,000. Does everybody see how easy it is? It comes from one new piece of knowledge. And then the rest is just, oh, I get it. Now, look at C. C is ugly, correct? Right? What if C was this? And don't write this down. Just look. What if C was x squared cubed? What would you do? That would be x to the 2 times 3, correct? Because over a bracket, we multiply. Okay? Do I have an exponent going over a bracket? So what do? Multiply. What is 1/3 times 2?
1.
What is 1 tape measure times 2? 2 tape measures. So what if I had 1/3 of a tape measure? No, it's not. I would get the 2/3 of a tape measure. So this is 8 to the 2/3. Now do I know what to do? Where does the denominator go? To the index. Where does the base go? To the radicand. Where does the numerator go? To the power. What is the cubed root of 8? 2. Squared. What is 2 squared? 4. And I'm done. Everybody cool? Ease peas lemon squeezy, right? Okay. Let's go to B. I have a base and a fraction exponent. Where does the denominator go? Index. Where does the base go? Radicand. Where does the numerator go? Power. What is the cubed root of 27? 3, because it's 3 times 3 times 3, right? I want a group of 3. Out it comes, 3 to the 4th. What is 3 to the 4th? What's 3 times 3? What's 3 times 3? What's 9 times 9? 81, and we're done. Does everyone see how easy this is? What's weird about D? It's a decimal, but that's not too bad, is it? What should we do with that decimal? Which is?
49 over 100.
49 over 100, correct? And that is to the 1/2. Where does the denominator go? Index. Where does the base go? Radicand. Where does the numerator go? Power. What's the square root of 49 over 100? 7/10. To the first power, do we change it? No. What's different about E? It's a decimal exponent. But isn't a decimal just a fraction? What is 1.5 as a fraction? 15 over 10. Now, would we ever leave that written that way for Mrs. Bad Crumble? What would we do with that? To what? 3 over 5. 5 over 3.
3 over 2.
3 over 2. No, it isn't. You said 5 over 3. 16 to the 3 over 2. Where does the numerator go? Index. Where does the base go? Radicand. Where does the numerator go? Power. What's the square root of 16? 4. Cubed. What's 4 times 4 times 4? Remember I said memorize the first 10 cubes. What's 4 times 4 times 4? 64. Right, kid. Good one. Okay, what's weird about F? Anything? It's a decimal, so what should we do? That is 75 over 100, but we don't write it that way. How do we write it? 3/4. Now I have 81 to the 3/4. Where does the denominator go? Where does the base go? Radicand. Where does the numerator go? Power. 4th root of 81. 3, because we just did it right here, right? 3 cubed. What's 3 cubed? 27. And we're done. Now, hopefully you've all noticed something about these ones. They've all been pretty easy, right? Like 81 had a 4th root. 16 had a square root, correct? Now, you're not unintelligent. Do all numbers work out this perfectly in math class? Of course not. So why did I start with these nice easy ones? To get you to see this relationship. Okay? That's why we're doing it. And then base to radicand. Easy? Easy. Now, what's wrong with down here? This is in what we call exponential form. Because it's got a base and an exponent, correct? Right. I can also put it in radical form. Which is what? What would it look like? No. How would I write it out as a radical? 5 fifth root of 8 squared. Right? Everyone agree? Right? Okay. Now, so the squared is right there. Everyone agree? Now the squared up here, I left the square on the outside, yes? But could I, or the cubed on the outside, could I have put it under there?
Yeah.
I could have, right? It would be the same thing, yeah? So this is either, this, the 5th root of 8 squared. And why is that a problem, Satcho? You were saying it already? 8 does not have a 5th root, does it? Right? What's the biggest root 8 has? Doesn't have a square root. Doesn't have a square root. Has a cube root. So this we're stuck with, aren't we? We could also write it like this, the 5th root of 8 squared. Everybody with me? Now, what is 8 squared? 64. Can I simplify that? That is 32 times 2. 32 has a 5th root. It is 2 5th root 2. Doing it the long way. Does this give me any kind of real life answer? Could you go to Home Depot and say, I need 2 times the 5th root of 2 lengths of rope? You could, and then the person would be like, what the hell are you talking about? Right? And then you would say, I know what I mean. I'm smarter at math than you are. Everybody understands what I did here, yes? But this is not a real life answer. So that is why I have this instruction here. If you're not going to get a 5th root, and you're in a position where you need an actual number, like physics class or something like that, you got to know how to do this. And you already know how to do this, because that's what we did up here to show you how all this works. I do 8 exponent bracket 2 divided by 5 close brackets equals. And it's a stupid little decimal, right? It doesn't matter. It doesn't matter. But when we simplified it, it's 2 times a stupid little decimal, which will give me 2 point blah, 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 blah. Does everybody understand? Okay. Now let's look at this one. Does this one have a chance to work out nicely like this in any way? No, it's going to be a giant mess because that's a decimal, right? So I'm going to look at that and I'm going to say, I can't do anything with that. The best I could do is I could do radical form. And what would rad form be? 7th root. You could put 6 over 10, or you could leave it as 0.6 to what power? 15. Right? And if you're going to do this on your calculator, I need a real world answer. What would we punch in?
0.6.
0.6.
To the power of 15.
Exponent button.
Oh, yeah.
Then what?
15.
Bracket. 15 divided by 7 bracket equals. And again, stupid little decimal, useless, right? What? Yep. It doesn't matter where it goes. Let me show you what I mean, because that's a good question, Satjo. Nobody needs to write this down. Terrific. Thanks. 16 to the 3 halves. Don't write this down. We know that's the square root of 16 all cubed, right? The square root of 16 is 4 cubed, and that answer is 64. Is everyone cool? Now watch. This is also the square root of 16 cubed, and I'll put the 3 under there. Everybody cool with that? So that is the square root of 16 times 16 times 16, yes? What's the square root of 16? 4, so what's coming out here? 4. What's the square root of that 16? So what's coming out here? 4. What's the square root of that 16? So what's coming out here? 4 times 4 times 4 is 4/3. Does everybody see how it's the exact same thing? Do you think I care which way you work with it? Who makes the decision about how you're going to work with it? You do. Whatever you want. All right? I cannot get in your head and tell you, do it this way. If I could, we'd all be getting A's, right? Okay. So, let's look at this situation in sort of a real life situation, okay? Here, I've been given a formula, right? Okay. Easy peasy lemon squeezy. My brain mass, B, and the mass of the animal in kilograms, M. Is this a question or a time when I want some weird square-rooted answer, or do I want the actual decimal? Why? Because it's a real-life answer. I'm trying to find the mass of something, right? I would not get on a scale and I weigh 200 pounds. I would not get on a scale and say I weighed 2 times 10 squared pounds. Would I? Right? That'd be stupid. I would not get on a scale and say I weigh the square root of 40,000 pounds. That's stupid. I give the real answer, yes? So even though we know how to do this with math, for this, it's a real life, it's science, we want the decimal answer. Everybody good? So would we use our calculator, or would we use all the numerator goes here, denominator goes here? What are we going to use? Our calculator, right? So let's do so. B equals 0.01 m to the 2/3. What's going in for m? 27 to the 2/3. Now we already know in our heads that 27 to the 2/3 is going to be 9, don't we? Because we know the cube root of 27 is 3, and we know 3 squared is 9, right? So we can do this one in our heads, because we know that is 0.01 times 9, which would be 0.09 kilograms, right? Easy peasy. We can do that one in our heads because it works out, like the first few questions we did, yes? Now, in reality, do animals always have perfect squares and perfect cube masses? Of course they do not. So let's check a polar bear. B equals 0.01 m to the 2/3. 0.01, what's going in for m? 200 to the 2/3. Now I got to punch that into my calculator. Is my calculator smart enough to do BEDMAS? Yeah, it is, right? So I can punch that in exactly how I see it. What would you punch in? 0.01 times 200, then what? Exponent button, whatever it is, then what? Bracket. 2 divided by 3, close brackets, and then what? Equals. I must have an equals to get my answer. And what is it? 0.03 or 0.3? 0.34 kilograms. Easy peasy lemon squeezy, right? You're always going to either be calculator or this thing, depending on what is being asked of you. Now, we're in math class, right? So which one are we going to use more of? Denominator here, numerator here, power here, or calculator? Denominator here, numerator here, power here. Because this is math class. If this was physics class, which would it be? Calculator. If it was biology class, what would it be? Calculator. If it was chemistry, what would it be? Calculator. Everybody with me? Yeah. So you guys punch this one into your calculator. I'm going to write out what you should punch in. And if everybody does it right, what do we get for an answer? 0.15 kilograms. Yeah, yeah? Yeah, yeah, yeah. Just like the Volkswagen commercial. Now, your homework, and you have not quite 20 minutes to begin working on it, is page 106. The answers are on page 107. As always, you don't have to if you're comfortable. But remember, being able to do 3A is probably not a good indicator of being able to do 18E, right? Everybody cool? Okay. If it were me, I'd make sure I did a few from each one. When I got down to number 11, or when I got down past number 7, and I'm feeling good about it all, I'd make sure I did a few with fractions and a few with decimals just to make sure. Okay? Okay. I'm going to add one last thing to you, just to remind you, even though you already know. X to the a over b becomes b root of x to the a power. Now remember, you can reverse that. If I have b root x to the a, it becomes x to the a over b. Remember, it goes both ways. Everybody good? Spectacular. I think I'm out of coffee. I am. It is X block this week. As you can see, not one person seems to think they need any help with math. It is indeed block C.